Hello, welcome to Homework Help for 5.2. My screencastify is finally working again, so yay. I have no idea why, but yay. So the Go section of your 5.2 homework is extra credit. It is a review from IM1, but we didn't review it in class, so you don't have to do it, but if you do, I'll give you extra credit. Okay. Here we go. Below is a set of common mathematical symbols. Your job is to match them to their definitions. Are the symbols logical? All right. So you have a list of symbols on the left side and you have definitions on the right side. You are matching them. Okay. So for instance, number 1, you have an equal sign. So what definition over here talks about an equal sign? No, 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 no. Used when comparing numbers of equal value. Yes, that is when you use an equal sign for. So that is F. Oh. F. Number 2, the measure of angle C. That's how you read that. The measure, that's what the M is, of angle C. All right, let's see. Which one has to do with the measurement of an angle? J indicates the measure of an angle. It would be set equal to a number. So like it would say the measure of angle C equals 75 degrees, or the measure of angle C equals 100 degrees, whatever it equals. So that is J. Now let's look. If you look at the left side, we have a bunch, well, 4 of GHs. We have a GH here. We have a GH with this line on top of it. We have another GH, another GH. All right, so let's look at our GHs. All of their definitions are going to have GH in there somewhere. So let's start with, I guess we'll start with number 3. Number 3, GH. Does this represent a line segment with endpoints G and H? Does this represent a ray? Does this represent, where else is it? The length of GH or the infinite line of GH? If you know, write it. If you're not sure, I'm going to switch over and I'm going to do, actually we'll go down to the next one. We'll go on to the next one, the next GH. So this is GH and it has a line on top with 2 arrows on the end. So which one do you think that is? It has a line with 2 arrows. So is that representing a line segment, a ray, the length of GH, or is it the infinite line? It is P. It's the infinite line because the line on top is going on forever in both directions. That means it goes on to infinity. So this is P. Right. The next GH I have, let's look at the line on top. It's just a straight line. There's nothing there. So that one is going to be the length. So that is the length of GH. That is N. And then we have this one, GH with, this is called a ray on top. Okay, where it goes on forever in one direction only. So a ray goes on forever just in one direction. So that is ray of GH, which is E. So that's E, which means our last one must be the line segment. So this one is D. But I think you can do the rest of these through the process of elimination. Then you have the set problems. So for 15 and 16, they want you to construct a perpendicular bisector, which we did in class. If you don't have a compass to use, it's not the end of the world. You just kind of have to estimate. I'll show you an example of that right now. My phone keeps going off, but I don't see it. It's kind of obnoxious. Oh well. Anyways, so when you construct a perpendicular bisector, like we did in class, so I'll do number 15. If you have a compass, you would put your pointy end on B. Okay. and then you would extend it so that the pencil part is more than halfway across. Right? And then you would draw an arc. So I'm going to draw an arc and put a mark. So there's like an arc here, and draw a mark below, an arc below. So I draw an arc down. There's a mark like right there. Okay. And then keeping your compass the same width, put your pointy end on A, keep your compass the same width, and go ahead and draw an arc. So you would draw it up, and it would intersect. And you would draw it down, and it would intersect. Okay. You can then connect these two intersection points with a straight line. Let's see if it lets me do it. Oh, geez, I did that. I estimated that badly. Hopefully yours is a little bit straighter than that. There. I'm just going to fix it so it's a straight line. My bad. I did not do that very evenly. So this intersection point should be on the line. But you would have a perpendicular bisector. So it cuts this line in half, and it makes a right angle. So you're going to do the same thing for 16. 17 through 19, you have to construct an angle bisector. All right? They kind of give you a diagram to show you how. I'm not sure how helpful that is, but anyways. So bisect an angle means you're going to cut this angle in half. That's what bisect the angle means. We're cutting it in half. All right? So we have to figure out where that is, and you're going to do that if you have a compass with your compass. So the first thing you're going to do is you're going to put your pointy end, if you have a compass, put your pointy end on B, and then extend the pencil part out. It doesn't matter how far out you go, just stay within the angle, so like don't go all the way out here, but maybe like to right here. And you're going to draw an arc. Oh, I just put a dot. That's not very helpful. Let's see if I can draw an arc. That's not that bad. Okay, I'll take it. So I draw an arc. Ignore my little red dot. Okay, and then from this point right here, where it intersects the original angle, you're going to put your pointy end there. Okay, and then you're going to, so put your pointy end here. Boop, and then you're going to extend the pencil part out. Once again, it doesn't really matter how wide you go. So maybe like to right there, you're going to draw a nice, you would draw a nice big arc with your compass. Okay. And then you do the same thing. So you would put your pointy end on A, and whatever width you had your compass, keep it there. So your pointy end is on A, extend it out the same amount, and you would draw another arc. Right, and they should intersect. If you want to draw the full circles, you totally can. Right? But then your perpendicular bisector, your angle bisector is going to go through this middle point and through your angle. So like that. Right. Ta-da. And then it wants you to mark your bisected angles as congruent. So just, you see, let me change the color here. So this angle right here is congruent to this angle right here. Okay, we know that because we just cut this angle in half. So this angle is congruent to this angle. All right, so you're going to do the same thing for 18 and 19. Here we go. 20. You're going to be using the Pythagorean theorem. I think you can do it. 21. We did one very similar to this in class. Do your best. Remember that all three of these have to add up to 180 degrees. Should I give you the Pythagorean theorem? No. Okay, 22 is a little bit of a level up problem. We're not doing anything different. It's kind of a puzzle. So you're trying to figure out x, right? They tell you that BEC, CED, and DA. Okay, so triangle BEC is a right triangle, so that means this is a right angle. Triangle CED, okay, this is also a right angle, that makes sense. And DAB are all right triangles, D, A, B. So this is the right angle. There we go. So all three of these triangles are right triangles. You are trying to find x. Did it say that in the directions? Okay, yes. Okay. So, you're going to be using the Pythagorean theorem this whole problem. I need to find x, okay, which is part of this triangle. The problem is I only know one side of this triangle. So how do I figure out the other side? We have to start figuring other things out. So what can I figure out? Look at my other three triangles, or my other two triangles. What can I figure out? What side can I figure out? Pause me and think about it if you didn't. Okay. Well, I have this triangle right here. B, A, B. Oh, I lost it a little bit. Okay, I have that triangle. Right? I know that one leg is 8, the other leg is 15, so I could figure out the hypotenuse of that triangle. So let's go ahead and do that. I guess I'm going to give it to you. A squared plus b squared equals c squared. Okay, so let's maybe we'll call this something. Let's call this triangle Bob. Okay, so we're going to find triangle Bob. We're going to find the side. So A is going to be 8, so I have 8 squared plus b squared, b is 15, equals c squared, which we don't know. So now this is what we did in class, right? So that's 8 squared, which is 64, plus 15 squared, which is 225, which is, I don't know, this is where I need one of my mental math kids to be in here. Where the heck? Oh, I found it. Oh, hold on one second. Oh. Okay, it's fine. I think I have an important email, but it can wait. All right, so you get 289. Sorry, 289. Oh, sorry. G's. C equals c squared. There you go. 289 equals c squared. Right? The last step is to take the square root. So take the square root of 289. Square root of 289. And you get 17. So c equals 17. Cool. So we now know that this side, this purple side that I highlighted, that whole thing is 17. Okay, great. But we need to figure out this side. We don't know this side still. We know it's going to be less than 17, right? Because this whole side is 17. So now what do you think we can do? Let me get rid of my highlighting. I'll label, I'll just know we could label this. All right, over here, BD 17. Goodness gracious. Okay, so we know that. Now, what else can we figure out? What other side? Well, we also have this triangle right here. Okay. One leg is 6, the other leg is 14, so we can figure out C. So go ahead and try that and let me know what you get. Well, you can't let me know. Never mind. Go ahead and try by yourself. So let's say A is 6, B is 14. What's C? Pause me and try it. Okay, so then we're going to substitute 6 in for A. So that's 6, oh my goodness, 6 squared plus 14 squared equals C squared. 6 squared is 36 plus 14 squared. 14 times 14 is 200 and 14 times 14. Oh no, it's 196. Equals c squared. Keep on going. 36 plus 96. That is, I don't think that's a perfect square. Square root of 232. Yeah, it's not. You get like c equals 15.23. 2315, so on and so forth. Okay, so now we know that this side right here is 15.23. And we know this entire side is 17. So how can we find this side? How can we find ED? Okay, sorry, I forgot you could pause me. So we can take this whole line, BD is 17, right? We know that part of it is 15.23, so the rest of it is just 17 minus 15.23, which gives you 2.23. Or, sorry, not 2.23. Goodness gracious. Let's leave it like 1.77. It's close enough. All right. Whew. We're still not done. But now we know that this side is 1.77. Our original goal here was to find x. So now we can find x. Let me get rid of my highlighting here. This is our last triangle. Okay. Now that we know this side, we know the lengths of both of the legs. That doesn't make very much sense. They did not make that look very to scale. No, okay. I think it's going to come out right. Okay. Let me delete this. So now, let's say A is 6, B is 1.77, or the other way around if you want. So that's 6 squared plus 1.77 squared equals c squared. So 36. Use your calculator. Okay, they threw in a decimal, so they're trying to mess you up. So let's just do 1.7 times. So you get 3.132. So okay. Oh, yeah. Equals c squared. Okay, that is 39.13132 equals c squared. Then you take the square root. Hold on. I don't know. The square root of 9.132. So I got 6.25. C equals 6.25. Probably means I think that means I disagree with the book. I do. Awesome. Okay, hold on a second. Okay, well, I just did it again, kind of, and I got the same thing. So I'm going to go with that. So C, so this is actually X. It was just the hypotenuse. That's why I put it as C. So X equals 6.25-ish. 23, a little bit harder again. Given CF bisects ECD, so CF bisects ECD. So if it bisects it, that means it cuts the angle in half, right? So CF cuts this big angle in half. That's what bisects mean. bisect means. They tell us that ECF is 2x plus 10. ECF, so that's right here. This is 2x plus 10. Okay, and they tell us that FCD is 3x minus 18. FCD is 3x minus 18. Wait, I lost what I was doing. FCD. They. I'm looking. I thought this is what I thought. I'm looking at it again. They threw in this extra segment just to mess with you. This extra ray just to mess with you. CG is not going to affect your problem at all. I wonder if they meant to label it something. Oh well. So, anyways, CF bisects the big angle. Ignore CG. Pretend it's not there. So that means that this angle should be equal to this angle. We don't know how big it is, but we know that these are equal to each other. So you can just do 2x plus 10 equals 3x minus 18, right? Because when this line bisects the angle, it cuts it directly in half. So this side is equal to this side. Remember, we're pretending that CG is not there. Okay. And now you're just solving for x. So I'm going to subtract 2x from both sides, minus 2x, 2x. So that gives me 10 equals x minus 18. Then I'm going to add 18 to both sides, right? I'm going to add 18 to both sides, so x is going to be equal to 28. All right, so x equals 28, but you're not done. They want you to find the measure of angle FCE. FCE. So this angle, which is 2x plus 10. They want you to find this measurement. Well, you know x is 28, so you're just going to substitute that in. So it'll be 2x plus 10, so 2 times x is 28, plus 10. So 2 times 28 is 56 plus 10 equals 66. I think I agree with the book on that one. I do. So it is 66 degrees, and you are done. There should be a little degree symbol, which I don't have on this program. So 66 degrees is your answer. All right. All this is extra credit. If you want to keep watching, I'll go ahead and go through it. Go through some of it. All right. So they want you to label point C, E, D with the correct order of pairs. So just label them. So like C is at 1, 2, 3, 4, 4, 0. E is at 1, 2, 3, 3, 1, 2, 3, 3, 3. And D is at 0, 4. Yes. Okay, that's all they wanted you to do for the first part. Just put your coordinates in. And then what are we doing? We are translating. So we're translating down 4 and 6 to the right. I'm going to translate down 4 and 6 to the right. So that just means you move the whole thing down 4 and 6 to the right. So I'm going to start with C. I'm going to move it down 4. 1, 2, 3, 4, and 6 to the right. All right, and that is my new C, which I'm supposed to label C prime. So you're going to do the same thing. You're going to move E. Wait, now I forgot. Down 4 and 6 to the right. Yeah, wait. Yeah. Okay. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Okay, cool. So that is my new E. Okay, and then D, down 4, and 6 to the right. 1, 2, 3, 4, 5, 6. Ooh, barely fits. Okay, and let's label that. Right. Go ahead and make sure you go ahead and just connect those with the lines. So let's see if it'll let me connect. So C to E. It's one line. E to D. Oh, that didn't quite go. There we go. D, and then finally C to D. Ta-da! So I've translated this triangle down 4 and 6 to the right. All right. Okay, so these, they want you to draw in lines connecting them. I'm not going to do this part. You can do this. So like you're going to connect C to C prime, E to E prime, D to D prime, and then find the slope. Oh, what is the slope of these lines? Well, yeah, and then find the slopes. All right. So you can do that. Reflect. So now we're back to this triangle. Reflect triangle CED across the line, across the x equals 0 line. All right. Oh, my bad. So when you reflect over x equals 0, that is the y-axis. So D stays in the same spot. Oh, that's the one. Not the one. D stays here. E, just move it. So when you're reflecting, it's going to be the same distance from the line. So E is 1, 2, 3 away. So it's 1, 2, 3 away over here. Okay, you're creating a mirror image. So that's E. And then C is 4 away. 1, 2, 3, 4. So it's 4 away over here. 1, 2, 3, 4. Okay. Voila. So that's E and C. Nope, sorry, not E. Oh yeah, no, that's right. C and C. Okay, and then once again, you would connect those to form your triangle. Okay. I'm going to let you answer the rest of 27 without me, or try it without me if you want. The last thing you're doing is rotating CED 180 degrees about the point negative 2, 0. All right, I'm going to get rid of some stuff here so we can see what we're doing. Okay. About the point negative 2, 0. Okay, so negative 2, 0. So right here, we're rotating around this point. There are a few ways you could do it. The distances just become the exact opposite. For instance, C is 2 in the negative direction away, right? It's 2 in the negative direction away. So then C prime, or whatever we're on, C with 3 dots, yeah, is going to be 2 in the positive distance away. So it's going to be right here. So when you're rotating 180 degrees, the distances just become negative. It'll be easier to see when we do E. So right now, E is up 3 over 1. Here. E is up 3. Oh, which way over? Left one? Left. I don't know why that went there instead of an E. E is up 3, 1 left. From our rotation point. 1, 2, 3 to the left 1. That means when you rotate it 180 degrees, it just becomes E is, or whatever, E with the 3 dots is down 3, right 1. So you do the opposite things. So it would be down 3, 1, 2, 3, and left, and right 1, and right 1. So there would be your new E. So this is E, 1, 2, 3. And this was C. So then go ahead and try D by yourself. Pause me and try it. Okay, so here's our point of rotation. D is 1, 2, 3, 4, up 4, right 2. You could also be drawing using a protractor, but that's okay. For what I said. Up 4, right 2. Okay, so then D 1, 2, 3 is just the opposite. So it's down 4, left 2. So instead of up, we're down. Instead of right, we're left. So we are down 4 and left 2. Okay, and then you would connect all your lines. I'm getting lazy, obviously, but there you go. So we rotated this 180 degrees around the point -2, 0. All right, and that is it.